Okay, there we go.
Okay.
X equals 7.
X equals 7. Yeah. So, well, wait. Is it because it should be 8x equals 56? Yep. X equals 7. Okay. Got it. All right. Let's see here. So we got a new one here. All right. All right. This is the perimeter of PQR is okay. Okay, so triangle FGH, and sometimes I guess you draw these FGH. So FGH is similar to triangle PQR. PQR. And it's important that you draw them in the same order each time. You can draw them whatever order you want, but in the same order. They tell you that PQ is 10, FG is 6, and the perimeter of PQR, so the perimeter over here is 35. And they want the perimeter of the other one. All right. They want the perimeter of this one on the left. So the picture helps to kind of clarify this. The just like the sides are in ratios, so are the perimeters. So if we call this x, the perimeter x 35 over, and then 6 goes with x and 10 goes with this one. So now you just solve the proportion again. So these two numbers on the left go with the smaller triangle. These two numbers on the right go with the larger triangle. Were you able to come up with a solution for that? Julia, how you doing on this?
Oh, I got 21.
Okay, I'm so sorry. I didn't know that you had already worked that out. Yes, that's correct. It's at 10, x equals 210, x equals 21. Great. Okay, let's move on to number 10, and keep charging through this. So, a lot of proportions. A lot of these problems are very similar. You're setting a proportion, then you're solving it. Um, So if you can write the correct proportion, you're going to get the correct answer most of the time. So we have a 5-foot tall student, and they cast a 4-foot shadow. So that's 5-foot tall student, 4-foot shadow. There's a tree, and we don't know how tall the tree is. We'll call it height h, casts a 44-foot shadow. So what is the height of the tree? So we're going to write a proportion again, and I've been doing it. There's a lot of ways you can do it, but we're going to set this h equal to the 5. So these two are going together. Well, the h has to go with the larger triangle information. So this other side down here, this side down here. So you're setting up the proportion for h equals 220. So h equals 55 for that. All right, let's look at the next one. So for sure, you're going to probably see that you're setting up a proportion for this. Find the value of x. Okay, so which side does x go with? You got to make sure that the only thing you're probably trying to make sure is like, is this the side that it goes with? And it does. So x goes with 15. 24 goes with 18. 24 goes with x because it's part of that triangle. 18 goes over here. If you don't mind, could you solve this one for me, please, and let me know the answer? All right, hopefully you got something like 18x equals 360, x equals 20 for that.
Yeah, that's what I got.
Great. All right, number 12. Okay, so number 12, which theorem or postulate can be used to prove two triangles are similar? All right. Well, I think one of the things that might be good here is to cover, which ones are possible to be used. So you can definitely use angle, angle, and you can definitely use side, angle, side. And then I'm pretty sure you can use this. This one I don't believe you can use. So now it's just a matter of like, well, which are you given? Like angle, angle, angle means this is usually used with right triangles. So that one's possible, although we don't necessarily have all the information. Side, angle, side means that generally the triangles, they have this like overlap on them where they share an angle.
Mm-hmm.
And then the side similarity, to me, this is almost like it's kind of like a weird donut where you have the triangle inside the triangle.
Mm-hmm.
They don't share any vertices, but they do share that. So like I could go either way on this, because if this is 27, then this is 63. If this is 63 and this is 27 degrees, you have, to me, this is either A or B, because you have the angle between the two sides. But they don't give you the other side. So that's why I'm not sure how they want you to answer this, because if you're trying to find this side, like let's say this was X, you would use the fact that you have a side, angle, side. But if you're just proving that the triangles are similar, it's probably A because you have two angles and it's a right triangle.
Mm-hmm.
So I guess I would tell you it's A. The solutions come with this, and as far as I remember, so take a look at that if you need to, and you can confirm that if you want for us. But the other information is very important, very practical here. Okay, on to number 13. In triangle ABC, A to B to C, DE is parallel to AC. If AD equals 12 and BD equals 3 and C equals 10, find BE. So we're trying to find this X. What I think is unclear here about this picture is that there's really two triangles, And sometimes it's better to draw them, the two triangles here. This is 3 and this is x.
Mhm.
This is 15 though. It's not 12, it's 15. It's 3 plus 12. And down here it's x plus 10. Like this thing over here on the left is nothing. This is not useful. It's only useful when it's attached to the larger triangle.
Mhm.
Since we're trying to find x, we can say x equals, and it's related to the side over here, x plus 10, 3, and then 15. So you have to be able to set it to proportion, and then of course you have to be able to solve it. The way I've been setting it up is this direction, and then matching the other side with the triangle on the left. There's other ways to do it, but this is how I've chosen to do it today. So just be comfortable with how you want to do that. Diagonally multiply here, so 15x equals 3 times x plus 10. 15x equals 3x plus 30. Subtract 3x. Divide by 12. So x equals 30 divided by 12, which is 2.5. So it looks like it's that one there, or that one there. So once you write the equation, you have to be able to solve it. And most of these are just proportions that we've seen thus far.
Okay.
All right, find the value of x. This is kind of the same deal, although they don't give you they don't give you it's not a triangle this time. Do you mind checking the answer for this one?
Okay.
I think you're going to say 15. I just want to confirm
Yeah.
before I go and do that. So this one's a little bit odd because there's no triangles here. There is a triangle here, but it's not really relevant. So these are what are in proportion. You have this x over 10. I'm sorry, x goes to 10. And then you got this 24 and 16. So ends up being 16x equals 240, and then x equals 15 when you divide by that. So it's a little different than the last one because you don't have to do this 10 plus 16 because it's not a triangle and it's x plus 24.
Yeah.
But I don't really like that, but that's that's the way of this problem. So I guess these aren't really in any particular, like, they're not giving you like the sections, they're just giving you problems. So almost all these are proportions that we've set up so far. So that's you definitely retest on a bunch of that. Okay, so the triangles are
Okay.
similar. The triangles are similar here. They want you to find the altitude KL and WX. Oh, they want you to find KL. So they want you to find this X over here. This is KL. So X goes with what side over here? It goes with 3 on the right. So now you need another side over here on this triangle. That's 28, and that goes with 12. So you can solve this. 12x equals 84, and then x equals 7.
Okay.
Then I guess they give you a few weird ones, a little bit different ones here. Find the value of x. There's x. So x goes with 10. You just see, okay, that's 10. Okay, now we got to figure out, well, what, we know that 10 goes with 16. So we got to figure out, well, does 16 go with 9 or does 16 go with 12? See how this angle right here goes with this one on the left? I'm sorry, the left goes with the right. That means that it's 12 down here. And I think this problem is just designed to like maybe have you try to choose 9 instead of 12 for that. So you have 16x equals 120. Divide both sides. 120 divided by 6 is, not sure. Let me check here. 120 divided by 16, 7.5. Moving on to scale factor. So a little bit hard to see, but triangle A is here, kind of highlighting it again. This bottom length is 4 units. B's bottom length is how many units? It's 6. So 4 to 6, what's the multiplier to go from 4 to 6? Well, it's essentially like solving 4 times k equals 6. K is the dilation scale factor. So to solve for k, you divide by 6. K equals 6 divided by 4, which is 3/2 or 1.5.
Okay.
This is if we're going through it too quickly, let me know. We'll just pause a little bit each time. A little more time to catch up on reading the problems maybe as well. Nathan is building a model of his father's sailboat with a scale factor of 1/32. That's K. The actual sailboat is in the shape of a right triangle with base of 8 meters, hypotenuse of 13 meters. We draw that if we want. 8. Base of 8 and hypotenuse of 13. What will be the approximate perimeter of the sail on the model boat? So this is one of those where I don't know that much about boats. Is the sail, is this the sail? Or is this the sail? Oh, the perimeter. Okay, I'm sorry. I didn't catch that. So the perimeter means we have to find all the shapes here. Okay.
Okay.
That was unclear. So the actual sail, this is the actual one here. Okay. So we need to find this third side. Okay, I'll call this B. How do we find the third side of a right triangle? Pythagorean Theorem, right?
Yes.
So we have 8 squared plus B squared equals 13 squared. So B squared ends up equaling 169 minus 64, and then you take a square root of that. I'm shortcutting a little bit of the steps here. 105. The square root of 105 is B. So the perimeter. This has got a lot in it. We had to find the perimeter of this thing of this. So the perimeter of this thing is the square root of 105 plus 8 plus 13. So that's the perimeter of the actual. The model though is 1/32 of this. So once you get this number, whatever this number is, we're going to take it and we're going to multiply it by 1/32.
Okay.
And that should give us one of the numbers in the answer key. Except it gives us something else. Actual sail, the shape of a right triangle, base of 8. Oh, they're switching units. Okay, well that's another issue. Okay, so wow, really odd. So the number I get when I find the perimeter here is about, it's like 31.24.
Hmm.
So when you divide it by 32 or multiply by 1 over 32, you get 0.9764, but that's in meters, and all these answers are in centimeters. So you have to multiply by 100 to get to centimeters. So it's 96.64 centimeters, or 97.65.
Okay.
Okay. Okay, so next problem is to find the geometric mean between the two numbers. I need to look up this formula because I don't remember it. Geometric mean. Okay, so it's the square root, and the 2 is not necessary, of 20 times 5. So it's the square root of 100, which is 10.
Okay.
All right. Find x in triangle ABC. Okay, so another probably proportion we're setting up. A lot of proportions. Find x and triangle ABC. Okay, so this triangle has a small triangle, a medium triangle, and a large triangle. There's 3 triangles in there. X is 2 things. It's the short leg of the medium triangle, and it's the long leg of the small triangle. So what you generally do is you put x in the top left position, and I'm just going to call it the long leg of the medium triangle. So do we have the long leg of anything else? I'm sorry, it's not. It's the long leg of the small triangle. Sorry, I wrote that wrong. It's the long leg of the small triangle. So do we have the long leg of anything else? Yes, we have the long leg of the medium triangle. So the medium triangle's long leg is 16. What else do we have of the small triangle? We have the short leg. The short leg is 4. And then do we have the short leg of the medium triangle? Well, not really, but we have it in terms of x. It's x there. So you set up this this table where you fill in the values, and that gives you your proportion here. So it's x squared equals 64, x equals 8.
Okay.
You could maybe even eyeball it, I guess. I don't know. It's yeah, I only see one of those, so so there's an entire section in your book dedicated to this, but maybe it's just a small portion of the final. Okay, find x in triangle PQR. This is whenever you're given a right triangle, it's Pythagorean theorem. A squared plus b squared equals c squared. Your a and your b and your c. So you have 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. So 169 equals c squared. Take a square root of both sides, so c equals 13. All right, moving on to 22. Find x in triangle STU. So this is, again, it's a Pythagorean theorem. You got x squared plus 15 squared equals 17 squared. That's a squared plus b squared equals c squared. Will you go ahead and solve that for me, please? And let me know what you get for an answer.
Okay, I got 8.
8 is correct. All right, 23. Moving along here. So 23, there's some rules here that I'm gonna actually type because they're more wordy than anything. There's 2 conditions, so I'll do it this way. Condition 1, hopefully you see that when I'm typing. Condition 1 is that the sum of the 2 smaller sides is larger than the largest side.
Mm-hmm.
So for example, 2 plus 3 has to be greater than 4, and like that is. Okay.
Mm-hmm.
Condition 2. Condition 2, the difference between the largest and medium side is smaller than the smallest side. This one's a little more wordy, but it's like saying 4 minus 3 has to be greater than 2. I'm sorry, it has to be less than 2. I wrote that wrong. And that is, okay. So that usually the easier one is like add the 2 numbers, like 7 and 11. Is that greater than 14? Yes. Is 14 minus 11 3 less than 7? Yes. Okay. So which of these is not the right? Did I maybe miss? Oh, I'm sorry. I miswrote this one. I'm sorry. This has to be greater than. Why am I writing this wrong? 4 minus 3 is 1. This is bad. I mean, so this is, sorry, this is bad. Let me rewrite these. So 14 minus 11, that's fine because it's smaller than that. The difference has to be sorry, I'm losing myself here. 4 minus 3 is 1. 1 is smaller than that. Oh, I'm sorry. I'm so sorry. I'm doing the wrong problem. None of this applies. Sorry. Right triangles. I didn't catch this because these all work. We're looking for the one that a squared plus b squared equals c squared. And for the first one, it's like 2 squared plus 3 squared. Does that equal 4 squared? The answer is no. 7 squared plus 11 squared equals 14 squared. The answer is no. 8 squared plus 10 squared equals 12 squared. The answer is no. So it must be the last one. I'd like you to verify this, that when you add these up, that it does equal that squared.
Okay.
Should get 225 equals 225 for both of them. All right, we're going to pause here and just take a 10-minute break. Just use the next booking email for the link for going to the next lesson. We'll start in about 10 minutes.
Okay.
All right, I'll see you soon.
Okay, thank you.